Hello, everyone. Thank you to Martin for inviting me to give this lightning talk. I wanted to talk to you about my perspectives on essentially a twist on this loss function as a boundary object idea. My name is Ed, and I'm from the Brain SIR team here at Google. So why am I qualified to talk about this? Well, first of all, I was an HCI researcher with some connections into the CSCW community. And in particular, I did a lot of work in social computing. But since arriving at Google, my team actually have been working quite a bit on recommender system, notification systems, and classification systems, and have made more than 300 improvements across many different product surfaces here at Google. And in particular, my team has focused across these four different pillars: neural modeling, reinforcement learning, responsible ML and fairness, and as well as robustness techniques for ML systems. And these four pillars interact in very strategic and important ways. I don't have the time to actually discuss them in detail, but I'd be happy to answer questions or discuss with you during the panel. Now, with that aside, I wanted to make 3 points around this idea of boundary objects. And the first one is this idea of objectives versus loss functions. Now, product and user objectives are indeed often translated into loss functions. And so the premise of the discussion that we have today certainly makes a lot of sense to me and is not lost on me. However, there are some complexities here, and of which I want to bring up two. The first one that many of you may already know about is something called the Goodhart's law. And this is one little pesky problem is that oftentimes what we have found inside of Google is that whenever you propose a measure to be a target, indeed, it turns out that it often ceases to be a good measure. So here's a nice little illustrations of this. If you measure people on the number of nails made, then what you might end up getting is thousands of teeny little nails that are not very useful to you. On the other hand, if you measure people based upon the weight of the nails that they're making, then you might end up getting a few giant, very heavy nails because that's the fastest way to create weighty nails. And then what happens is that those nails are probably not very useful to you as well. So this concept of Goodhart's law has been well known in the sociological and economic circles, and sometimes it's also referred to as Campbell's law. And there are subtle differences between the two, but the point is that metrics are pesky and they're difficult to work with for these reasons. The other point I wanted to make about loss functions as boundary objects is that oftentimes loss functions are actually situated within a wicked problem. Now, in case you're not familiar with this concept, the concept of a wicked problem is that it is a problem that is difficult or impossible to solve because of incompleteness or contradictory or changing requirements that are very dynamic and very difficult to recognize. It often refers to ideas or problems that cannot be fixed, perhaps, for example, in time, or where there's no single solution to these problems. And the wickedness here, by the way, doesn't refer to the fact that the problem is evil. It just refers to that the problem has a resistance to eventual resolution. So, in fact, another definition to the problem is that the social complexity is so high around the problem that there's no deterministic stopping point. And because of these complex interdependencies, efforts to solve it becomes very problematic because it just continues to reveal other problems, kind of like peeling back an onion. So I want to illustrate this by examples that I know about. So for example, when you're building recommender systems, in the past, before say 5, 6 years ago, a common technique would be just to simply optimize for a single objective. But when in fact, nowadays it's become much more common to actually solve for multiple and diverse set of objectives using neural architectures that look like this. So this is an actual architectural diagram that we presented as a recommender neural architecture in a RexSys paper. Now, these neural architectures are actually really interesting. Despite the fact that maybe perhaps some of you have not had any experience doing neural modeling, but even that diagram can kind of give you a sense of what's going on in the system, in that there are multiple objectives that you're trying to optimize at the same time. And brings me to the second point I wanted to make about these neural architectures as boundary objects. These boundary objects are defined to be things that crosses community of practice. So that means that business owners, engineers, executives, as well as perhaps external researchers can look at these objects, these architectural diagrams, for example, or definitions of loss functions, and be able to understand them, to make sense of them, And the fact that they're plastic, meaning that you can actually make changes to them, that gives you that communicates the kind of improvements that you would like to make them objects that actually have a kind of design ability to it that enables communication, right? So Charlotte Lee has talked quite a bit about these kinds of boundary objects as negotiation artifacts in collaboration, and indeed, these neural architecture diagrams and the neural architecture ideas essentially become those negotiation artifacts in our collaboration with business owners, users, and other key stakeholders. So I think this idea that boundary objects can be communication vehicles for different community practice indeed does play out. And importantly, the idea that these boundary objects does cross different community of practice, that product managers, business owners, and engineers and researchers can all use them to communicate with each other is a very important concept that actually does work out in this setting. Now, what I showed you earlier is essentially an idea map, right? So a map that gives you an idea of how you might be able to change these architectures to further your goals, right? So maybe you can add additional tasks, or you can ask additional experts, or that you should be changing inputs instead of just thinking about the neural architecture. Now, it turns out that, of course, these neural architectures can be drawn at different scales, at different granularities, and so we can create different details for different actors or different communities of practitioners in the space. We can also make them extremely more detailed so that engineers have specifications to get real understandings of how components interact with each other. So for example, here is a more detailed diagram that we presented that shows how mixture of expert and idea for neural architecture can resolve task conflicts between multiple objectives, or to create these shallow towers to factorize bias and variance problems in the system. The third point I wanted to make is that neural architectures are combined with objective and loss functions are actually learning objects. Now, why am I mentioning that? Well, one of the things that I learned when I looked up the Wikipedia article on boundary objects is that there's this article by Anne Balsamo and one of her collaborators, I know Anne, so I'm referring to her, talking about that there are these boundary objects that are actually learning objects. In particular, she was talking about this in terms of a distributed collaborative course and how objects within that course turn into essentially pedagogical materials that can be easily annotated and modified and passed around. And more importantly, that these materials can evolve to archive the meaning of their use in particular situations. So in the context of a classroom, they will have a particular meaningfulness, but when you take them home and use them as part of your homework, they take on a different situation and a different meaningfulness. So I think of loss function and neural architecture diagrams in particular, having some of these very similar capabilities. They do serve as pedagogical material to communicate for engineers to communicate with each other and to business owners and product managers. And they are indeed easily annotated and modified, and they do evolve over time. And so from that perspective, it fits these definitions. So those are the 3 points I wanted to make, that business objectives or user objectives indeed can be translated into loss functions, but they're not singular, and that you need multiple objectives. And loss function is not enough, that you need neural architectures combined together with loss functions. In fact, loss functions is part of it. That together seems to form a kind of boundary object. And then finally, they're beyond boundary objects. They really combine together to form a kind of learning object. So perhaps I can summarize my entire point by a single thesis, which is that product objectives in systems like recommenders and notification systems and classification systems are not just summarized into these single loss functions. As an example, recommenders are actually dynamic wicked problems that are socially complex. And it's very, very difficult for us to say that, okay, we're done with designing these recommenders, because often they're just evolving social environment in which these recommenders live in. What this all implies is that what we need are learning objects, such as these neural architecture diagrams, that allow us and help us to archive and make sense of the evolving complex problem. Thank you very much.